Right, this session we're looking at box and whisker plots. Box and whisker plots are another way of representing data, and they build on work from cumulative frequency. So if you haven't yet revised cumulative frequency and you're unfamiliar with the concept of median, upper quartile, lower quartile and interquartile range, there's no point you practicing this topic. So go and get your head on cumulative frequency and then come back to it. If you're on top of cumulative frequency, we're ready to go. Okay, zoom in a little bit. So Iona needs to give a presentation to her work team. The boss has asked her to include a box and whisker plot in her presentation. Iona works in the sales team, selling new telephone systems to large companies. She had been given some sales data by her boss as shown below. Cheapest system, most expensive system, median, lower quartile, upper quartile. On the graph paper below, draw a box and whisker plot using the data that Iona has been given. Okay, so the first thing we need to do is to make sure that we've got a scale that will fit this box and whisker plot nicely, and we need to make sure that we can fit on both the cheapest and the most expensive. So we need to go from minimum of 30 up to 140. So if that's 0, 10, 20, 30, 40, 50, 60, 70 isn't going to do it, so we're going to have to go up in 20s. 20, 40, 60, 80, 100, 120, 140. So that's going to be our scale. And just like with any graphical representation, it needs to make sense. So it needs to have the units of what we're measuring, which is in pounds for sales. So sales in pounds. You can't see what that looks like, but I'm in the right mess of that. Sale in pounds is what I've scribbled there. Now the box and whisker plot hasn't got a y-axis. We just want to make it sort of symmetrical with where we've got. So the box and whisker plot looks like this. Okay, and each part of it is a representation. That bit is the minimum value. This is the maximum value. This is your lower quartile value. That is your upper quartile. And that is your median. So that's now what we're going to draw within there. So these whiskers are going to be, I'm going to put them along that line so it's nice and symmetrical, and I'll grow my box from there to there. So the cheapest system is the minimum value, which is 30, which is there, and the other extreme is the most expensive, which is going to go there. Then my lower quartile is 50, so 50 is here. The upper quartile is 100, so 100 is there, and the median is 60, so the median goes there. So then all I got to do is join my box together and send my whiskers out. And that's it. That's what the data looks like as a box and whisker plot. Question 2. The table gives a group frequency distribution for the lengths of the electrical cords of 80 toasters. So the first thing to do with any set of data is make sure you understand what the information in the table is telling you. It's usually worth picking a column and working out the story behind it. So what this column here is saying is that there are 38 toasters whose electrical cords are between 54 and 58 centimeters to the nearest centimeter. That one's saying there are 4 toasters whose electrical cords are between 64 centimeters and 68 centimeters. Okay, so I got my head around what that information is saying. Complete the following cumulative frequency table. So there are no toasters with a cord length of less than. Now the reason why that is 49, but this is written as less than 48.5, is because that's been rounded to the nearest centimetre. And if you have a cord length of 48.6 or 48.8, that would round to 49 to the nearest centimetre. So that's important to see why that is doing what it is. 6 fewer than 53.5, and it's 53.5 because if you had 53.4 it would round down to 53, and so on. So the way that the cumulative frequency works, as I've said, you practice this, you already know, you're going to get a running total going here. So less than 58.5 are those 6 and those 38, making 44. This one would be 44 plus 32. Excuse me. Which is 70, I gone brain dead now, 76, and then 76 plus 4, and you should always end up with the total that they tell you in the question. Okay, so that's your cumulative frequency table, which you're now going to turn into a graph, and you plot on these values. So 48.5, let's get our head around the scale first of all. Going up here, you're going from 0 to 20 in 10 little squares, so we're going up in 2s. Here you're going 5 in 10 squares, so each little square is a half unit. So 48.5, halfway between 45 and 50 will be 47.5, so 48.5 will be another half unit along. So that's going to be drawn there. 53.5 is 6. Well, that's 52.5 halfway. 52.5, 53. 53.5 is 2 squares along, and that's going to be 6. 2, 4, 6. 58.5, that'll be 57.5, so it'll be 2 squares along, and that's 44. 2, 4, 2 squares along. 63.5 is 76. 62.5, 2 squares along. That's 70. 2, 4, 6, 2 squares along is there. And finally 68.5 is 80, which will be there. So those are the points. Now you can either join those freehand or using a ruler. Either is acceptable with the cumulative frequency graph. I tend to find that the answers given on mark schemes are read off one that is joined with a ruler. So you might want to bear that in mind and play safe. They always allow a degree of tolerance in the answer, but it might be worth bearing that in mind and using a ruler to join them up. So that's my cumulative frequency diagram. Okay, where do we go next? Use your cumulative frequency diagram to find an estimate for the median, the lower quartile, the upper quartile, and the interquartile range. Okay, so you should be comfortable with that from your cumulative frequency work. Median is going to be halfway through the data, so we're looking for the 40th value, which is there, and we read off there. $57.5, median is going to be 58. The lower quartile is at a quarter of the data, so that would be at 20. So we read that one off. That would be 55.5. Upper quartile will be at 3/4 of the data, which is 60. And you need to be as accurate as you can be. Take care with this. So that's your upper quartile, and that would be 61. So the interquartile range would be the difference between the upper quartile and the lower quartile, which would be 5.5. The length of the shortest electrical cord is 50. The longest is 68. Draw a box and whisker diagram to illustrate the lengths of the electrical cords. So again, from symmetry point of view, I'll work from there. Really doesn't matter, but it just looks nicer. So shortest is 50, so that's one end of my whisker. 68 is the other. 67.5, 68. Median at 58, so the median 57.5 is one in from there. Then I've got my lower quartile at 55.5. And my upper quartile at 61. And do my horizontal lines. I get an ink everywhere. Make sure you do this using a pencil in the exam, in case you go wrong. And there you go. So that's the box and whisker diagram representing that data. Excuse me. Question 3. The table gives a group frequency distribution of the arm lengths of 100 women, each measured correct to the nearest centimetre. So again, I'm going to pick a column, this one, and what's it tell me? It tells me there are 15 women whose arm length, measured correct to the nearest centimetre, is between 159 and 161. When I accumulate that, because it's rounded to the nearest centimetre, you can see that 161.3 would be in there because it rounds to 161. So that's why these upper limits are being used. Okay, so then we get a running total, 0, 5, next one would be 20, 55, 95, 100. There's the running total. Then we're going to plot that, and we plot it on these upper limits. So 155.5, you can see there, these are going up halfway between 155 and 156 is where my 0 is. 158.5 is 5. On this axis is going up 2, 4, 6, 8, 10. So we're in the middle of that square. 161.5 is 20. 164.5 is 55. 167.5 is 95. And 170.5 is 100. So make sure you plot those as accurately as you can. Again, I'm going to go and use a ruler to join those together, which does go against how I would teach it actually. I would always encourage students to draw a freehand curve through the points. There you go. So that's our cumulative frequency graph. Use your cumulative frequency diagram to estimate the median and the interquartile range. Okay, so 100 pieces of data. So the median's at 50. $164. Lower quartile will be at 25. So that's going to be at 161.8. Upper quartile will be at 75. Which will be 166. So I don't know why I'm going to write that there. And right over here. So the interquartile range is going to be 166 less 161.8, 4.2. Use the graph paper below to draw a box and whisker diagram to show these results. Now this time they aren't telling us what the minimum and maximum arm length are. So what we have to use are the 0.5 and the 40.5 because we know those are the limits. So our graph needs to go between 0 and 40.5. So let's take a look here. What can we do? Hang on a minute, that's the wrong axis, it's the wrong data. This is what I want. It needs to go, well, pretty much we repeat the axis that we've got there. So we'll start at 154 and I'm just going to write them going up in twos rather than ones, just so it's quicker. And that's arm length in centimeters. Okay, I'm going to draw it from there, the whiskers along there, just for symmetry, so it'll look nicer. And the minimum value is 155.5, so 155.5. The maximum value is 100 and there's where the 155.5 has come from, and the maximum value 170.5 is going to be there. So there's my extremes for my whiskers. The lower quartile is 161.8, which was there. The upper quartile is 166, which is there. The median is 164, which is there. Then we can join up our horizontals. One there. Whiskers. Close the box. Job done. Question 4. Company is considering changes to its price list for delivering parcels in a local area. This is a parcel context. The company is considering a charge based on the distance between the warehouse and the destination of the parcel. The table gives the group frequency distribution for the distances measured to the nearest kilometre for 60 parcels. Pick this column. This is telling me that there were 30 parcels who was delivered between 11 and 20 kilometres from the distribution centre. It's drawn to the nearest kilometre, which is why these upper limits and lower limits are what we're measuring from. It's cumulative: 10, 40, 55, 60. 60 parcels, that's fine. Plot it. So 0.5, so we're going up, same scale on both axes. 1 square is 1 unit. So 0.5 is half in. 10.5 half in. 20.5 half a unit in. 30.5 half a unit in. 40.5 half a unit in. The examiner will be looking for that, making sure you're offset by that half a square. Okay, we'll just ignore that. So there's our cumulative frequency graph. Now, surprise, surprise, we're going to find the median and the interquartile range. So we've got 60 items of data, so the median's at 30. So reading that down, 17. Lower quartile will be at 15. Upper quartile will be at 45. So the interquartile range, difference between them, 12. For these 60 parcels, the shortest delivery distance is 2 kilometres and the longest delivery distance is 37 kilometres. Draw a box and whisker diagram. Okay, so shortest is 2, longest is 37. Lower quartile 12. Upper quartile 24. Median 17. With the median, the first one I think I've put as a dotted line. It doesn't matter as long as you're showing that they're there, the 3 lines. So there's your box and whisker. Previously the delivery charge was £2 for each parcel. The new pricing plan being considered is free delivery for all the parcels up to the median delivery distance and £4 per parcel for all other deliveries. Would you expect the company to profit from the new pricing for the parcel delivery? So previously all 60 would have cost £2, so they would have made £120. So that would have totaled 60 lots of £2, £120. If they're only charging for those above the median, well, the median cuts it in half. So above median will be 30 parcels times £4, which is 120, and free would be the other 30. So it'll make no difference to the company if they change their charging policy. Difference to the company. 120 quid either way. Okay, and that's using the fact that what the median does is cut the data in half. It's the middle value. Okay, final question. The information board shown below was seen by a river in the Italian mountains. The information board gives monthly data about the volume of water flowing past a cross section of river every second. So let's just get our heads around this chart then, because it looks pretty complicated. So we got a box and whisker. That's the maximum value in May. That's the minimum value in May. That'll be the lower quartile, the median and the upper quartile. And the dotted curve is the calculated mean flow every month. So write down the month with the greatest mean flow. So we're looking at the dotted graph, the dotted curve, and we want to see where it's at its maximum up the axis. So that actually is May, where we were looking at what that information tells us. So the month is May. Estimate this greatest mean flow of water, giving the units of your answer. So it's between 10 and 20. I would say it's more than half way between 10 and 20. So I would estimate that at about 17 meters cubed per second. So that's the flow there. I'll tell you what the accepted range is. Anything in the range of 16 to 18 would earn you the marks there. Part B. Which month had the smallest range of water flow? Estimate this range. So the smallest range of waterfall would be the smallest gap between the whiskers, between the maximum and minimum. So I would say that that is going to be February. And estimating that range, I would say that that is 4, and that is maybe 7. So the range 3 cubic meters per second, and they would accept there any value between 2 and 4. So that's fine, we're within that range. Which month had the greatest interquartile range of water flow? So the interquartile range is between the upper and the lower, so we're looking for the largest box. The largest box is May, and I would estimate that that is a little bit below 20, so I'd go upper quartile 19.5, lower quartile 12, interquartile range 7.5. And there they would accept any answer between 7.5 and 9. So that's fine. Part D. The local newspaper publishes a picture of the river with a caption. The mean flow of the river for the year was blank. Complete this caption. You must show all your work in. Okay, so to work out the mean for the year, I need to find the mean flow for each month, add them up and divide by 12. So I am going to estimate that as a little bit more than 10, sorry, a little bit more than 5. So I reckon 5.5, 5, 5.5. Remember, we're following the dots here. 8. We've estimated that one as 17. That one I'm going 15. 12. 10. 8. 8. 14. 8. So 5.5 plus 5 plus 5.5 plus 8, 17, 15, 12, 10, 8, 8, 14, 8. I'm going to add those up. And I get 116, which I'm then going to divide by 12, and I get an answer of 9.6. cubic meters per second, and they would accept any answer between 8.8 and 10.5, so you've got quite a big range there based on your estimates, and they can't be super tight because you know, they really are estimates that you're working with. That's it. Cumulative frequency, box and whisker plots.